Hello, today we will be graphing linear equations and identifying their intercepts, getting us ready for Chapter 9. Please take some time right now to go through the warm-up. Evaluate if x equals -2, 0, and 2 into the linear equation below. Okay, if I evaluate for x equals -2, I am going to plug in -2 in for x and solve for the output. So y equals -4 times -2 plus 1. So y equals -4 times -2 is 8 plus 1, so y equals 9 if x equals -2. Now, if y equals 0, we'll do the same thing here and get y equals 0 plus 1, so y equals 1. Now I will evaluate if x equals 2. So y equals -4 times 2 plus 1, so y equals -8 plus 1, so y equals -7. So plugging in values for x and solving for y or our output will help us with today's lesson. Let's review linear equations. Do you recall what standard form for linear equations is? Well, if not, I will help you out. But think really hard because I bet you can remember. Good job, you got it. It's ax plus by equals c. C is called a constant or a number. Ax and by are variable terms. A couple rules to follow with standard form is that 1, a must be positive. And here, a is the coefficient that's in front of x, right there. There can be no fractions or decimals in standard form, and standard form must be in simplest form. Let's go through a few examples of putting the following equations in standard form. So again, standard form is ax plus by equals c. So as I look at number 1, I see y equals 3x plus 8. I need to have my x term, so 3x, be on the left-hand side. So I'm going to subtract that. So when I do that, I get -3x plus y equals 8. Now I think back to those rules that we just talked about, and I know that my first term in front of x, my leading coefficient, must be positive. So to get rid of that negative, what do? You guessed it, I multiply the entire equation by -1, or simply change all the signs. So I get 3x minus y equals -8, and that is standard form for number 1. Now let's look at number 2. 2y minus 4x equals 8. Well, first, I know I have to flip-flop x and y, so -4x plus 2y equals 8. Now, I see that my first term, -4x, is negative, so I know I will have to get rid of that negative. But I also see that within 4, 2, and 8, I can divide by a common factor. I can divide by 2. So this equation is not, right now, in simplest form, and we need it to be in simplest form. So I'm actually going to divide by not only a negative, but a -2. So I can get rid of the negative to begin with here, and get this equation in simplest form. So when I divide by a -2, -4x divided by -2 is 2x, 2y divided by -2 is -y, and 8 divided by -2 is -4. And that would be simplest form for number 2. Now in these notes, I ask you, is x squared plus y equals 9 a linear equation in standard form? So as we look at that equation, a couple things should stick out. First off, I have x squared, x to the power of 2. Is that linear? No, it is not. If I had x plus y equals 9, that would be linear, but since I have this x squared, that is not linear, and that's what we're going to be looking at tomorrow and all throughout Chapter 9. That actually, with a degree of 2, you can recall, is called quadratic. Now let's review finding x and y intercepts of linear equations. What is an x-intercept? You guessed it. where the line crosses or intercepts the x-axis. And how can I find an x-intercept? You guessed it, find by setting y equal to 0 and solving for x. Now what is a y-intercept? Well, very similar to an x-intercept, but now where the line crosses or intercepts the y-axis. And I can find the y-intercept now by setting x equal to 0 and solving for the resulting y. So remember, to find the x-intercept, I set the opposite variable equal to 0, which would be y, and solve for x. To find the y-intercept, I would set the opposite variable, so x equal to 0, and then solve for y. Now let's take a look at finding the x and y-intercepts for 3x plus 2y equals 6. So to find the x-intercept, remember, I plug in 0 for y and solve. So here, into 3x plus 2y equals 6, I'm going to say 3x plus 2 times 0 equals 6, and now solve for my x variable. So 2 times 0 is 0, so I get 3x equals 6, divide by 3, so x equals 2. So this x-intercept here would be 2, 0, ordered pair form. Now the y-intercept, now for the y-intercept, I'm going to plug 0 in for x and solve. So 3 times 0 plus 2y equals 6, and solve for y. So 3 times 0 is 0, so I have 2y equals 6, divide by 2, so y equals 3. So this y-intercept in ordered pair form would be 0, 3. So with the x-intercept here, this tells us when our line crosses the x-axis, and here for our y-intercept, this tells us when our line crosses the y-axis of our graph. Now if we want to graph linear equations, let's use a few key points such as the x and y-intercept to graph these equations. So to graph using key points, the intercepts, we'll find both the x and y-intercept, plot both the x and y-intercept, and connect with a line. We will be doing this tomorrow with quadratic equations, which is why today with linear equations we are getting a preview. So let's look at the example. Graph by using the x and y-intercepts of 3x minus 6y equals negative 3. To find the x-intercept, again I plug in 0 for y and solve. So 3x minus 6 times 0 equals negative 3. And 6 times 0 is just 0. So 3x equals negative 3. Divide by 3, so x equals negative 1. So this ordered pair is negative 1, 0. Now for the y-intercept here, I'm going to plug in 0 for x and solve for y. So 3 times 0 is 0, so negative 6y equals negative 3. Divide each by negative 6, so y equals 1/2. So this ordered pair is 0, 1/2. I tried zooming in on this graph so we could see this a bit easier, and so I'm going to graph my x-intercept, which was negative 1, 0. So I'm going to plot that right about there. Okay, that's the x-intercept. Now the y-intercept, I'm going to plot at 0, 1/2. So I'm going to plot this about right there. Again, I tried zooming in so it'd be easier to see. And now I'm going to connect with a straight line to make my linear equation. I drew a line between the two intercepts, and this is my graph for this linear equation. Now we could also graph linear equations by making a table. So let's say we choose values such as negative 5, negative 3, 0, 3, and 5 for x values. We can plug in these x values into our equation to find our output y, which is what we did in our warm-up if you can recall, and we can graph this equation. First, we should make sure that our equation is in slope-intercept form, so this will be the easiest to solve for, and we'll plug in values for our table, and then we'll graph. So as I get this equation in standard form, I first need to subtract 4x from both sides. Because again, slope-intercept form is y equals mx plus b. So I end up getting 2y equals negative 4x plus 8. Now I need y to be by itself, so I'm going to divide everything here by 2 and get y equals negative 2x plus 4. Now I can go ahead and plug values in for x to find my output y. So I'm going to say here, I'm going to plug in negative 5, so y equals negative 2 times negative 5 plus 4. And negative 2 times negative 5 is 10. 10 plus 4 is 14. Now I'll plug in negative 3 for x, so negative 2 times negative 3 plus 4, and solve. And negative 2 times negative 3 is positive 6, plus 4 is 10. And now I'll plug in 0. Let's give a little bit more room here. So y equals negative 2 times 0 plus 4. Negative 2 times 0 is 0, plus 4 is 4. Now we could continue to solve for 3 and 5, but we really only need 2 points to make a line. And I have 3, but again I could keep plugging in 3 and 5 to get even more points. But I'm going to go ahead and graph now. So here is my graph, and I'm going to graph 0, 4 first. So I'm going to go over 0 on the x-axis, up 4 units. So that would be about right there, 0, 4. Now I'm going to go over negative 3, up 10. So that's actually going to be right there on my graph. And then negative 5, 14 will actually be off my graph, somewhere about right there. Now I have my 3 points. I'm going to connect and make my straight line. And while I make this line, recall that with the linear equation, you should have a straight line. So if you notice that your points don't look like they could connect and make a straight line, you may have solved for a point incorrectly, or you may have graphed a point incorrect. And this would be the graph for the equation 4x plus 2y equals 8. And here, we again used a table to graph this linear equation. Here, once again, was all of our work. Thanks for listening. Have a great day. Bye.